I hope screen is visible clearly. Is the screen is visible clearly? Sujata? Jeevan? Okay, we'll start the class. So let it be on. Okay. Some of them are on hold. I think they are in call. See what happens, why I am asking others to join the class. If they miss the class, they won't understand the remaining problems. They won't understand the concept. Later, they will only blame that we are not understanding the classes. Correct? Is it right?
Sir, I told them also, sir. I called yesterday all students, sir.
Hmm.
They telling me, sir, that we are facing the network issue. I don't have net pack. They told him like that.
It is not the way because they are going to miss the class and they are going to, you know,
Face the problem.
face the problems. That is the problem. It's their responsibility to attend the classes.
Sure. So let's start the class. Meanwhile, they are going to join, sir.
Anyhow, it's okay. So, in this class, I would like to introduce the method of sections. In previous class, we have already solved the method of joint. In the method of joint, we have considered each joint and we have solved and members which is associated or connected to that member, to that joint. So, in the complex trusses, like many number of members are, number of members are too much, and in that case, if you consider each joint and go on solving the members, it is too huge. So in that case, we refer the method of sections. So here, actually, what is method of section? So in general, what we do, that is finding the reactions, right, and for the support, and after that we need to consider the members where only two unknowns are there. From that point, from that joint, we are going to start the problem that is proceeding, right? So in the method of section, we can analyze taking a sectional view, that is having a left hand side and the right hand side of the given trusses. So here. When the finding the reactions, we will not be able to find a joint where there are only two unknown forces. So in that case, we cannot analyze the truss by method of joint. That is the reason. And here, the particular truss is showing here and this truss will be having members of that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 members are there. So in these 11 members, if you go on solving by joints, so how many joints are there? 1, 2, 3, 4, 5, 6, and 7. 7 members, and 11 members and 7 joints are there. So keep on solving the method of joint. You might be facing the problem at certain point, and you need to move on to another joint. What we have done in the second problem in method of joint we have discussed. So for that reason, we need to consider the method of section. So this method of section, when the method of joint fails to start or proceed due to non-availability of a joint with only two unknown forces, even after finding the reactions. That means whenever the reactions are found out, after finding the reactions, we cannot analyze the truss is because there are more than two unknown members that is there in the particular joint. Apart from that, when forces in only few members of a large trusses are required for that is that in easy way, if you discuss that only 2 to 3 members are to be analyzed for a huge truss. If you're having a trust with 15 to 20 members, in that 15 to 20 members, you're going to ask to calculate, or you need only few of the members forces. So for that reason, we cannot go for joint method of joints. In that case, we need to go for method of section itself. I hope it is clear for you. And let us take the only this example. If you here we have n number, many numbers of members are here, but it is asked to calculate only the force in the FC and force in the BC. So in that case, if you start considering the method of joint, you need to go for joint number one, that is joint number A or joint number E, and then move on to other joints. But if you consider a method of section, you can directly find out the force which is asked to calculate for the particular member, right? And that is the case we can prefer for this method of section. So in one word, if you say the method of section is superior method, superior method of joints in the particular discussed conditions. What we have discussed for, that is when it is fails to proceed or start for a method of joint. In that case, it is superior to consider over a method of joint. And after this, if you want to analyze given truss by method of joint, you need to take a section. The section should be having an equilibrium condition on either side of the truss, either side in the sense left hand side and right hand side. So here the equilibrium of each part, if you obtain, that constitutes a system of non-concurrent forces. The concurrent forces are at the point which are acting, but non-concurrent are which are not acting at the same point, right? So we have three equations of equilibrium for these kinds of systems. Hence, using them, that is forces, equilibrium forces in the member, and the cut can be determined. That means a section can be determined, and it may be observed that the forces in the three members should be non-concurrent. For example, if you take a section for this truss, the section should not pass through more than three members. It should be passing through only maximum of three members. It should not get passed through more than three members. And along with this, we need to observe the non-concurrent forces are to be there in the member. Concurrent forces should not be there. Concurrent forces in the sense the section where it passes, it should not pass through the point where the load is acting, right? So non-concurrent, otherwise the moment equilibrium conditions will not give the useful equations in this condition. For that reason, the sectional view need to be taken at the members, not at the joints. After this, we may use this method as an advantageous over a method of joint when there is a need for finding forces in only few of the members as in the large truss, right? This is one of the advantage if you write for the section method of sections. So whatever now we have discussing, it is all about the theory part for this truss, and you may ask to calculate or ask to write for the advantages of the method of section over method of joints, or else you may have to ask to write what are the conditions to solve the method of section over method of joint. That means when do you choose to solve the method of section by the for the truss, so, right? So when do you start solving the method of section is when there is fails to start or proceed the method of joint due to non-availability of the joint with only two unknowns. It may be having a three unknowns over here. After that, another condition we could say, that is when forces in only few members of the large truss are required. That is the case, we can consider this as a method of sections advantageous, right? This is all about the LHS, that is you know method of sections. So when the method of section is considered, the main point to be discussed with LHS and RHS. So whatever we have discussed in the method of joint, that is considered for the particular joint, and we have determined the members which is connected to that joint. But here it is not like that. It is to be considered like LHS and RHS. Left hand side of the section, right hand side of the section. That is what we need to consider over here. So with this discussion of a brief about a method of section, we can now continue with determine the particular problem. Then we could be easily understood by the what is exactly the method of section is. Now let us take a problem here. The truss is given and asked to calculate the forces in all the members, right? So here in all the members, in the sense if you start joining the method of joint, let us take a discussion for the joint for this truss. See here, there is again at the initial stage only you will be finding three members are here at that particular support, right? However, there is a reaction on this and there is an horizontal force over here because due to the pinned joint. Even if you start from this joint, you cannot be able to start it because see here it is, you will be observing three members, right? But for method of joint, it is required only two members. Again for support E, here also you will be having the three members, you cannot start it. And if you move to joint number D, if you move to joint number T, again here it is three members, G it is also having three members, and C it is having four members. That means this particular truss cannot be analyzed by having the method of joint. I hope it is clear for you people why we are choosing method of section for the given truss. Is that clear why we are choosing this section?
Yes, sir. Yes, sir.
Right? Okay, so this is the case. So after this, after knowing the particular given truss is solving for the method of section, so which section do you need to consider over here? So the section, if you consider that section should be having an equilibrium condition on either side. An equilibrium condition on either side in the sense you have to observe the how many members are there on either side. So here if you choose this section what I am shown in the dotted line, that section if you choose, the BC member will be having an force acting as a force, and FC member will be acting as a force. Apart from in the section we are getting F4, that is AE force or AE member. So these three members will be considered in the section. If you solve the particular section and the forces on this and the section on left hand side is 40 kilonewton and right hand side will be having 40 kilonewtons, right? So again if you consider a section at this case, you'll be having the same, that is CD and GC, right, and EA, right? Apart from that we cannot take any other joints. If you take this joint, we cannot have an equilibrium condition at this position. and if you take the section at this position, it will not be in equilibrium. And however, we have that this condition that the particular section should not pass through the load, that is concurrent forces should not be there on the section. That means the point load or any other load should not be acting to that section. In that case, we need to consider this one, or else if you consider in any of the other way, the members should not be greater than 3.
Hello, sir.
Right? Yes.
Sir, that slide is not changing, sir.
No, I am not changing the slide. I am just explaining these things.
Yes, sir. Okay, then.
Okay, if you consider other section other than this point, this position, the particular members will be having, it should not be having greater than 3. And after this, if you replace or misplace this section towards this position or any other position, the section should not be, it should be in equilibrium. It will not be in equilibrium. That is the case. We need to consider the section here I have considered, right? And if you start solving the section for the particular given stress, it will be looking like this. The truss section is shown here, and the angle is provided, and the data which is provided for the truss need to be known before solving the problems. So what it is given, it is exactly passing through the center of point, and the section is taken for the 4 meter from the left hand support. So in this, there is a left hand support and there is a right hand support. So left hand support and right hand support, you can consider any of the one. So it is better if you consider the left hand support, since we can have an that is only one force which is acting over here. If you consider on this side, we will be having the two forces, and will be having a lengthier one to know to calculate, right? So let us know how to solve on left hand side. Later we'll know about right hand side. So if you consider the section, it will be looks like this, and the height of the truss is given as 4 meter, and the section passes through the point, this point, and that point is denoted as H, which is exactly at the perpendicular to the member AE, that is written AH, right? And the section will be passing through BC and FC, right? That is, do remember this diagram, then we'll be considering some of the points while discussing the remaining things over here. So here the reactions need to be found out. However, we need reactions for the particular supports. So reactions, if you consider at the case, the moment is to be considered at the joint, and that moment is to be force is to be multiplied with the distances, like that. But here, if you observe this case in a smart way, the particular truss will be having symmetry through its center axis. Since it is symmetry through its center axis, the particular load will be having are distributed equally on either side of the supports. See, if the particular load is 40 kilonewton over here, this load is 80 kilonewton, then we could not have an symmetrical axis because the loads are unsymmetric. In that case, we cannot have the reactions equal on either side. Since here all the loads are equal and having symmetry about both the axes, in that case only we can consider the reactions as half of those total vertical load. I hope it is so common thing we have already discussed many times. So here, due to symmetry, you can have, that is, vertical force at A and vertical force at B should be an E. Vertical force at E is, there are 40 kilonewton load of three members and three joints acting, and that is 120 kilonewton of total load. Those 120 kilonewton of total load is acting on two supports. That will be having 60 kilonewton on either side. So now I would like to have that discussion for the 1 second. because I need an truss. Right, I hope it is clearly visible for you now. For clear discussion, it is being taken like this. Is it clearly visible now? Both the
Yes.
okay, okay now. See, after solving the reaction forces, it is now we are moving to the main section. In the main section, what we are doing is the section where it is passes, the forces need to be considered. That means now we are considering the left hand side of the section, that is A, B, F and AE, that is these members are considering. In these members the section is passing through BC and FC and AE. Am I right? So BC, FC and AE. I hope you are able to see the cursor. The particular section gives the forces of AE, BC, BF and BC. Sorry, FC, BC and AE. These are the three force members are, you know, uh, gives this considered section. Since there is a no joint where there are only two unknown forces, what we have discussed right now, for method of joint fails to start. So for that reason we are taking the method of section. So for this method of section, taking the section of this one, that is section 1-1, it separates the truss into two parts and cuts only three members. Right? It separates two parts and after truss and cuts only three members. So here, if you see, the moment need to be considered because whenever you start to solve the forces in the member, it is need to be considered on horizontal forces, vertical forces, and moments, right? So here, for solving the forces, included or induced in the force of FC and BC, right? For that reason, and that is AE. For that reason, we need to have a movement for the section considered on left hand side, right? Please do observe the cursor also along with the discussion, taking place here. So here in this section, if you consider, if you take the moment of this point, then we could write the moment equation as, since there is an horizontal force over here and this force will be having the perpendicular distance of 4 meter. So here that is nothing but AE, that we can write AE, that is the force. Then this force is having the perpendicular distance of 4 meter moving in anti-clockwise, right? FE for perpendicular distance of 4 meter for the joint C. I am taking the member moment at C because we need to find out the forces which are arise due to the section taken over here. We cannot start over here, we cannot start these members, we need to start for these members, and in these members we need to take the moment for the point C. So AE into 4, which is an anti-clockwise, that is minus AE into 4 plus 40, and 40 which is acting 2 meters from this. Since it is acting 2 meters from this, it is again remained with 2 meter for the particular section, that is at the half section, and that's 40 into 2 for the see, this is the particular load is considered this point, and that is also same at this point, and this into the perpendicular distance will be giving the moment about C, that is 40 into 2, and remaining we have a vertical distance of 60 meter, 60 kilonewton of 4 meter distance to the point C. Why I am taking the point C at this point is because in a horizontal plane, if you take the perpendicular distance will be this one, which is vertical, and in a vertical place if you take an forces, the horizontal, the perpendicular distance will not be there, because in vertical section it will be lying in this point, in this plane only. The point C will be lying in this plane only. I hope you are understanding, right? So here the forces considered at the support at A, or vertical forces at A. This vertical force is considered for the movement to the point C, then the perpendicular distance will be this one only. It is not the perpendicular distance, right? It is the perpendicular distance for the point C, that is PA into C, that is giving a clockwise direction, since that is 60 into, yes, that is giving an anti-clockwise direction for the particular force, that is 60 into 4, that is once you solve this, you will be getting 40 kilonewtons, that is 40 60 into 4, that is 240, and we have 80 kilonewton of total load, that is 40 into 8, which is acting the downward point load, and 4 that is total will be 240 minus 80 will be 160. 160 by 4 is 40 kilonewton. So since it is in positive, it is taken into an tension force. If it is a negative sign, it will be taken into an compression. So after this, so once we know that FAE is an 40 kilonewton, we need to determine FBC and FFC. So before determining these, we need to know that the internal angles, because internal angles is because some of the forces, some of the members are not given the internal angle over here. So here it is given 30 degrees, but here if you want to know the angle, just observe the truss. It is given 4 meter over here, and the height of the section is 4 meter. Since it is equidistance square, since it is equidistance square means it will be having an so I could draw over here to see, it is 4 meter length, it is 4 meter length, and it is also 4 meter, and it is also 4 meter. If you draw an diagonal for this, it will be having the 45 degree itself, right? So in the same case, if you consider this one, this is an 4 meter length, and from this it is a 4 meter length, and this is the diagonal line for the joint. Else I could take this an example for better understanding. one minute, it will get started. Okay. Okay, now see here, and from here to here. Okay. I hope it is clear. So this is the point that is taken rectangle like this, and this is the diagonal. Since this is 4 meter length and this is 4 meter length, and the section will be having 30 degree, 45 degree for this angle, correct? So here it is 45 degree, and it will be having 30 degree for this, and remaining will be 15 itself, right? Likewise, if you consider this one, see here, now consider angle C, that is angle CAH, angle CAH, H is considered at this point. Here you can observe for this one. CAH having an angle of, that is need to consider, and that will be 45 degree if you observe an equidistance square. And now if you consider that as the 45 degree, and remaining angle will be of 15 degree, which is ACF, we can say, sorry, CAF, that is angle between CAF is 15 degree. I hope it is clear for you. CAF, if you consider this angle will be 15 degree, and CAH is 30 degree, and total angle for this will be a 45 degree, what we have considered over here, that is 45 degree. In that 45, if you deduct the 30 degree, and remaining will be 15. That is what I have written over here. CAH is and total 45 degree, that is CAH. And now for CAF, if you consider, that will be of 15 degree, that need to be deduct of 30 degree. That is why we are taking this angle, is because we need to resolve the forces in the left hand side of the section. Right. So here, if you see the section over here, I will consider the vertical forces which are acting in the section only. We are not considering the joints, we are considering sections. So in the vertical section, if you consider, there is an 60 kilonewton of vertical load is acting, which is towards top and taken positive, and FFC, see here, FFC, which is taken at a section, you need to consider a section. FFC is taken moving towards positive, and here, see, this is, if it is 30 degree, here it is also 30 degree, is because here total it will be a 45 degree, here it is also 45 degree, correct? Because for this triangle, see, for this triangle will be having an this is 90 degree. If it is 90 degree, this should be 45 and this should be 45, correct? Hence, here it is having the 50 degree internally. Here it is having 15 degree internally. It is also having 15 degree internally, and remaining is 30 degree. Since here it is 30 degree and it is 90 degree over here, and remaining angle is 60. Is that clear?
Yes, sir.
Right, and remaining, since it is 90 degree, it is 30 degree, and remaining will be 60 degree, right? That is what written over here. That is 60, that is CFH, like this. What written? Just I will erase this things. Okay. Now, vertical forces are 60 kilonewton, which is moving towards top in the section left hand side. After that, in the section, if you consider FFC, which is moving again at the top, having sin 60, because we are resolving to vertical force. FFC is having 60 degree at this side. If you resolve this to vertical side, it will be FC sin 60 or FFC cos 30. Right? We can write FFC cos 30 and FFC sin 60 also. So cos 60 is because cos 30 is because remaining angle is 30 degree. If you consider on this side, that will be a cos. So 60 FFC sin 60, and remaining we have 1 minus 40 remaining load which is acting downward, that is minus 40. After that, once one we have, that is BC, that is a section minus BC cos 45. Cos 45 is because if you consider to the towards vertical direction, that is in the vertical direction force, the section, again the angle will come into picture. Since it is having total 45 degree, if you can take an axis, if you take an axis for this, since it will be a 45 degree and it will be 45 degree, total will be 90 degree. And if you resolve this FC to this vertical force, will be having 45 degree, right? So that is what we have considered over here. So now that is the 45 degree is considered. So once you resolve for this, so 60 minus 40 will be plus 20, and plus 20 is taken into right hand side, which is minus 20. So and remaining sin 60 is 0.866 FFC, and of course 45 is 0.707. So after this, once taken to horizontal forces, so horizontal forces, if you consider over here, see what are the horizontal forces that are acting in the section and in this left hand section. FAE is an horizontal section moving in the that is moving towards right, taken positive sign. Apart from FBF, one for sections only you need to take FBC, which is moving which is inclined. If you consider in the horizontal way, that is having the angle of 45 degree itself again. See, it is an angle for BC. So what is the angle? It is 45 degree, because if you consider a vertical force, this is also 45, and you need to resolve this force to horizontal direction, that is FBC cos 45. FBC cos 45. After that, FFC, if you consider that is also having an 60 degree, right? That is also having a 60 degree for this. FFC having 60 degree. If you resolve this to horizontal, that is FFC cos 60, right? FFC cos 60. So if the writing the equation and simplified way, FFC cos 45 is 0.7, FFC cos 60 is 1/2, that is 0.5, minus FAE. So taken into consideration, consider equation number 1 and equation number 2. So adding these two equations, you'll be getting like this, that is FBC is cancelled, minus 20 minus 40, that is here it is plus, and plus 20 is remain, and 0.866 minus 0.5 will be 0.366. So FFC will be 20 by 0.36 as 54.64. After this, once we knowing FFC as 54.64, we need to substitute in the equation number 1 or number 2, any of the equation, to find out FBC, right? So that is written over here like this. From equation 1, if you substitute the value of equation in the equation 1, you will be getting FBC as 95.20. So I hope it is clear what we have taken for the section. Is there any doubts regarding this? Please let me know, because it should be clear at this level itself. I think you'll be having doubts regarding this, because it is a complex considerations what we have observed over here. Arun?
Yes, sir.
Arun, is there any confusions while considering consideration of the forces?
No, sir. No, sir. It's very clear, sir.
Okay, remaining? So here almost Chandrika.
Yes, sir.
ನಾವು ಮಾತಾಡೋದು ಕೇಳತ್ತಿಲ್ರಿ ನಿಮಗೆ?
ಹಾ ರೀ.
ನೀವು ಕೇಳತ್ತೀನಿ ಏನಾದ್ರು ಡೌಟ್ಸ್ ಅದಾವ ಅಂತ.
No, sir.
So, is that clear what we have discussed?
Yes, sir.
However, after this completion of the problems, I will share the notes. Please go through the notes. If you won't understand there itself, then you can discuss in the class itself, no problem. Okay.
Okay, sir.
Everyone, please do solve the problems on your own, and if you got any doubts, please let me know in the class itself, or else you can contact me through the phone, and that I could give the solution for those problems. Okay, Andraj. Andraj,
Yes, sir.
are you listening?
Yes, sir.
Right. Today what we have started for method of section, it is quite complex as compared to the method of joints, but it is simple once you start solving the more number of problems. And don't miss the classes. Please join the classes and ask what listen what we are discussing in the classes. Everyone. So again, I'm telling you that if you have any doubts regarding the discussion taken place in the classes, or regarding any of the conflictions you are facing in the class, please let me know here itself, so that I could take over those conflictions, right? So please discuss your problems with me itself, so that I could give the solution for that. I hope you are understanding what I am telling.
Yes, sir.
Okay, with this, again, I request everyone to ask your friends to join the class, at least for the numerical classes. It is better, it is because of their betterment for future understanding the concepts. So for that reason, everyone please take a note on this, and ask everyone to join the classes. Okay, I hope we will do this one. And with this, we'll conclude this class. After in tomorrow class, we'll continue the problem, and I hope it is clear for you till what we have discussed now. Only thing is, the section need to be considered, and that section gives the left hand side, right hand side, and the left hand side or right hand side, we need to consider the vertical and horizontal forces. That is enough, right?
Yes.
Okay, with this note, we'll conclude this class today. We'll continue in tomorrow's class. Thank you for attending the class, everyone.
Thank you, sir.